Hi students, it's Kailash. Lesson number 9, Atomic Physics and Nuclear Physics of 12th standard. So in this lesson, you have an excellent and a beautiful, interesting topic, alpha decay. So write a short note on alpha decay. It's an important 3-mark question. So we shall see about alpha decay in this video session. Okay. Now before going into the topic, I really thank everyone who has subscribed to my channel. Those who haven't, please do subscribe to get my updates. Okay, thank you. Now we shall go into the topic, alpha decay. Now first of all, what do you mean by a radioactive disintegration or radioactive decay? So what does the term signifies? So you know that those elements whose atomic number is greater than 82 are radioactive. That is, those elements, the nuclei of those elements emit alpha, beta and gamma radiations. Now due to the emission of alpha, beta and gamma radiation, these nuclei are slowly and gradually gets modified into some other nuclei. So a radioactive nucleus, alpha, beta, gamma radiations emit பண்றனால வேற nucleus-ஆ வேற element-ஆ modify ஆயிட்டே இருக்கு. Now this modification will keep on until the nucleus attains a stable structure. Now this is what we call it as radioactive disintegration or radioactive decay. So the modification of a nucleus on account of emission of alpha, beta and gamma radiation is termed as radioactive decay or radioactive disintegration. If a radioactive nucleus undergoes a decay or disintegration due to the emission of alpha particle, then it is called as alpha decay. So that is what we are going to see in the topic. Now first of all, again, what do you mean by an alpha particle? An alpha particle is basically helium nucleus. It consists of 2 protons and 2 neutrons. So 2 proton, 2 neutrons or கூட்டு கலவாணி தான் யாருன்னா alpha particle. So ஒரு alpha particle எனக்கு ஃபார்ம் பண்ணி கொடுங்க அப்படின்னா 2 proton எடுத்துக்கங்க, 2 neutron எடுத்துக்கங்க, இந்த கடல் உருண்டையை உருட்டுற மாதிரி உருட்டி ஒரு spherical shape-க்கு கொண்டு வாங்க. So successfully நீங்க என்ன தயாரிச்சிட்டீங்கன்னா alpha particle நீங்க prepare பண்ணிட்டீங்க. So an alpha particle consists of 2 protons and 2 neutrons, which is nothing but the structure of helium nucleus. So that is why to represent symbolically an alpha particle, we use the symbol of helium nucleus. So He. I have to write the proton number in the subscript. That is nothing but atomic number. And I have to write the nucleon number in the superscript. That is nothing but mass number. So this is how an alpha particle is symbolically represented. And this letter is the symbol for the word alpha and not for alpha particle. So this is the alpha particle symbol, so don't forget that. Okay, so whenever a radioactive nucleus undergoes modification on account of emission of an alpha particle, then we are going to call it as alpha decay. So what really happens when a radioactive nucleus emits an alpha particle? So how the nucleus is going to modify? We shall see it. So let us consider a radioactive nucleus X. So let me consider a radioactive nucleus X. Let this nucleus contain Z protons and A nucleons. So there are Z protons, so atomic number is Z, and there are A nucleons, so mass number is A. Now this is going to emit an alpha particle. So you know the symbol for alpha particle is that of nucleus of helium atom. So 2He4. Now if you look at this equation, the radioactive nucleus on account of emission of alpha particle is ejecting out or is losing 2 protons. So originally the nucleus X was containing Z protons. Now due to the emission of alpha particle in fact 2 protons are ejected out of the nucleus. There is a loss of 2 protons. So what will happen to the proton number? It will modify, it will decrease. Whenever atomic number changes, the element has to change because each and every element will have a unique atomic number. But an element can possess n number of mass numbers. So we decide the element only with atomic number and not mass number. You know that. So since the proton number gets altered, X can no more remain as X. It will modify, it will take modification, it will act as some other nucleus because there is a change in proton number. Therefore, X can no more remain as X. It will become Y. Now, how many protons are lost? 2 protons are lost. Originally, there were Z protons. Therefore, the new proton number will be Z minus 2. And originally, how many nucleons were there? There were A nucleons. On account of emission of an alpha particle, 4 nucleons are lost. Therefore, the nucleon number, or in other words, the mass number of the new nucleus formed will be A minus 4. So thus, if you look at this equation, whenever a radioactive nucleus emits an alpha particle, the new nucleus formed will have atomic number 2 less than the original nucleus and the mass number 4 less than original nucleus. Now, the original nucleus is technically called parent nucleus. We can also call it as mother nucleus. But stick to the word parent. And the new nucleus formed is called daughter nucleus. Okay, and it's not son nucleus. பாத்தீங்களா அந்த காலத்திலே பெண்களுக்கு முதலிடம் கொடுத்திருக்காங்க. Son nucleus ன்னு வைக்க வேண்டியதானே. அதே daughter nucleus ன்னு வைக்கறாங்க. Okay. So daughter nucleus. So whenever a parent nucleus emits an alpha particle, the daughter nucleus formed will have atomic number 2 less than the parent and mass number 4 less than the parent. And not only this, in any nuclear reaction, in any nuclear reaction, the total masses of the products formed will always be lesser than the total mass of the reactants. இங்க இருக்கிறது ஒரே ஒரு reactant, ஒரே ஒரு nucleus. So the helium nucleus and there is alpha particle and daughter nucleus or a total mass எப்படி இருக்கும்னா it will be lesser than the mass of the parent nucleus X. Now this difference in mass between the initial nucleus and the final particles is called mass defect. So Mr minus Mp is equal to mass defect del M. Mass defect is denoted by delta M. Now as per a great scientist Einstein, whenever mass disappears, it should reappear in the form of energy. Mass can be converted into energy, energy can be converted into mass. Einstein's mass energy equivalence, E is equal to mc square. So as per Einstein, this change in mass or this loss of mass will appear as energy, which is called disintegration energy, denoted by the letter Q. Okay, so this difference in mass will appear as energy, which is called disintegration energy Q. So Q equals change in mass, that is del M, Mr minus Mp into C square. E is equal to mc square. So I am applying that formula. So I end up with Q equals to del M into C square. Now in fact, this disintegration energy, assuming that the parent nucleus initially at rest, of course nucleus has to be at rest. So assuming the parent nucleus to be at rest, assuming the parent nucleus to be initially at rest, this disintegration energy will be equal to the total kinetic energy of alpha particle and that of daughter nucleus. அதாவது நீங்க என்ன பண்ணிக்கணும்னா இந்த parent nucleus இருக்காரு இல்லையா அவரை ஒரு பிஸ்டல் மாதிரி இமேஜின் பண்ணிக்கங்க. So parent nucleus is a pistol மாதிரி அஸ்யூம் பண்ணிக்கலாம். Now the pistol is at rest. இதுல இருந்து நமக்கு ஷூட் அவுட் ஆகறாரு இல்லையா இந்த alpha particle. அத you consider it like a bullet. Okay? Now, the radioactive nucleus, that is the pistol, the parent nucleus, that is the pistol, which is going to act as the pistol, is going to shoot out a bullet, which is nothing but an alpha particle. Now alpha particle which comes outside the nucleus should have kinetic energy. Of course it's going to possess kinetic energy. As per Newton's third law, for every action there has to be an equal and opposite reaction, isn't it? Now X can no more remain as X because it has emitted an alpha particle. Therefore it becomes Y. Now what will happen to the daughter nucleus? You would have seen whenever we fire a bullet from a gun, the bullet travels forward, action, and the gun will recoil back, that is reaction. So like that, on ejecting out an alpha particle, on shooting out an alpha particle, the daughter nucleus will recoil back a little. So thus the daughter nucleus as well as the alpha particle, both of them are possessing energy. From where does these two get energy? During this reaction, there is a loss of mass. This mass appears as energy, which we call it as disintegration energy. And this disintegration energy is responsible for the kinetic energy of alpha particle and the recoiling energy of daughter nucleus. So by law of conservation of energy, the disintegration energy Q should be equal to sum of kinetic energy of the alpha particle and the kinetic energy of the recoiling daughter nucleus. Okay? And for any spontaneous process, any process which happens naturally, that's what we mean by spontaneous, this disintegration energy Q will be greater than 0, that is positive. And if in any nuclear reaction, the disintegration energy Q happens to be less than 0, that is negative, then that particular reaction cannot be spontaneous. It cannot happen naturally. We have to supply energy from outside. It has to be an induced reaction. So for induced reactions or induced activities, the disintegration energy Q will be negative, and for spontaneous processes, the disintegration energy Q will be positive, and for induced processes is going to be negative. Okay, right. So this is what we mean by alpha decay. Now let us just go with an example of alpha decay. For example, let me consider uranium, atomic number 92 and mass number 238. So this is going to be the parent nucleus. So it's parent nucleus. So what is it going to do? It's going to eject out an alpha particle. So when an alpha particle goes out of uranium nucleus, which originally contained, you can see uranium nucleus is containing 92 protons. On account of emission of an alpha particle, it is losing 2 protons. Thereby, the proton number becomes 90. Now, since the atomic number of the nucleus has modified, has got changed, it can no more remain as uranium. So, after emitting the alpha particle, the uranium nucleus undergoes modification. It will attain the structure of the nucleus, which will contain 90 protons, because atomic number reduces by 2 during an alpha decay. Atomic number 90 refers to thorium. And you can see there are 4 nucleons ejected out during alpha decay. So 238 minus 4 works out to 234. So thus uranium nucleus has modified and is now attaining the structure of thorium nucleus. So this is an example for alpha decay. See, whenever you write any nuclear reaction, don't forget to name the reactants and products as you do in chemical equation. So parent nucleus, right, uranium, this is alpha particle, just mention it, alpha particle, and this is your daughter nucleus, which is thorium. So I hope you would have understood alpha decay. So thanks a lot, meet you in the next video session. Until then, bye.